In this video we're going to look at the normal running mode of the DM2 unit. Normal running mode is the mode that you're going to use most of the time, and it's the only mode that you can access directly by pressing no buttons, as long as you make sure that before you power up, switch number 1 is to the left, which is the off position. So with switch number 1 to the left, the off position, we're going to apply power to the unit. It's going to tell us that we're going into normal running mode and go into normal running mode. So that is the normal configuration that you're using the car most of the time. Then you can see the most prominent display on the unit is the speedo, which has a numeric display and a bar gauge display, and a couple of bar gauges here we have as well, which are by default temperature and fuel gauge. We have a fully functional odometer and a fully functional trip meter. We also have a number of red-green indicators, which are represented by green to represent a high input to the unit, and red to represent an open circuit or a low input to the unit. So you can configure 7 different high side switched signals to the unit. In actual fact, you could configure them low side switched if you wanted, but that would involve a software upgrade. Okay, let's just apply a simulated vehicle speed to the unit to make the speedo work. And we're working at very low speed now, 4 miles per hour, and we can increase the speed, and we'll see that as we come up to 5 miles per hour, each of these LEDs represents an increase of 5 miles per hour. Actually, it should represent 10 miles per hour. That's because I have the high-low sensitivity mode on. We'll look at that in a moment. So normally, each LED on the bar illuminates with an additional 10 miles per hour. So 10 miles per hour, 20, you can see an additional LED for every 10 miles per hour. We have an externally accessible switch which allows us to double the sensitivity of the bar gauge. So if we put that on, you can see that we have an extra LED for each 5 miles per hour. But this is the mode that we normally use. This is just to make the display more colourful when driving at low speeds. You can see the trip meter started to advance now as well. We've done 0.3 miles, or kilometres actually this is set up for, because this particular unit is set up for a European customer. We'll increase the temperature on the test rig. We can see that the temperature gauge increases, decreases. We'll increase the fuel level. We can see that the fuel level increases and decreases. These little yellow LEDs here are indicating faults or range exceedances of the various sensors. On the fuel gauge, if I reduce the fuel right down so that it becomes less than about 3 LEDs, you can see that this LED illuminates. It just means that the fuel signal is going very low. In actual fact, if it goes to a dead short, then it will flash, indicating there's either a fault, either the signal is short circuit, or the fuel is extremely low. Whenever we get any fault on the unit, and a low fuel is just one of them, we have a number of fault indications. Let's have a look at these LEDs at the bottom of the board here. This particular LED here, it's a bicolour LED. When it's showing green, that means that there's no fault currently existing with the unit. So let's take this fuel signal low again and see that this LED goes red. So whenever there's currently a fault with the unit, this LED is red. Whenever there's no current fault with the unit, it'll go green. If there's a fault been detected on the current journey, this most significant digit on the odometer display will indicate F. And if there's been any fault detected in the last 64 journeys, this yellow LED will illuminate. So we have 3 levels of fault indication. This bicolour red-green LED indicates the current status of the unit. Are there any faults currently with the unit or not? Green for no, red for yes. This F is illuminated if there have been any faults on the current journey. So if there's an F there, that means there's been a fault on the current journey. And the yellow LED means there has been a fault in the most recent 64 journeys. We need to know that information when we look at the diagnostic mode, which enables us to retrieve fault codes. One other thing we need to look at now is these red-green indicators, what we have them wired up to by default. Let's look at these at the end first because they're the easiest to understand. This one is the reverse lights. Excuse me. When we put the reverse signal on, which is connected to the transmission, this red-green indicator goes green, and also the display shows a negative sign to show that you're in reverse. You wouldn't be going at 35 miles an hour in reverse, but that's just on the test rig. This one is secondary ignition power. Sorry, that's the wrong switch. This one is secondary ignition power. When secondary ignition power is on, it goes green. When the engine is being cranked, the crank signal is switched on and the secondary ignition power is switched off. To understand the detail of that, you really need to know about the actual way the wiring is done on the car. But suffice to say that each of these inputs, a high input switches the LED green, and a low input or an open circuit input switches it red. Now these first four are used for fault detection, and they're connected to the various points on the fuse box. The first LED indicates whether power is being applied to the engine's ECU. The second one indicates whether the ECU is applying its drive to the fuel pump relay. The third one indicates whether there is an output from the fuel pump relay, and the fourth one indicates whether that output is actually getting to the fuel pump itself via the fuse. So this final one indicates the status of the fuse, this one indicates the status of the relay, this one indicates whether the ECU is driving the relay, and this one indicates power to the ECU. If the power at any point is broken, it will detect a fault. We've already detected one fault on the module, which was a short circuit fuel input. Let's look at the temperature gauge as well, because the temperature gauge, when that goes high, that indicates a diagnostic condition, the same way when the fuel goes low indicates a diagnostic condition. If we switch the power off the ECU, all of those will go off, because obviously if there's no power to the ECU, it can't drive the relay can't produce an output, and the fuse can't produce an output. However, if we just switched off the signal to the fuel pump, which is simulated by this switch here, then we can switch that off individually. Some more telltale indicators we have here are connected to the left and right turn signals. So the left turn signal telltale, a right turn signal telltale, and the high lights telltale is also available there. If we have no signal from the speedo, we have an LED indicate here. That doesn't necessarily mean a fault, it just means there's no signal, which could be that you're just not moving. So let's switch that back on. The only other thing to look at in normal running mode is the other functions of this display here. This is normally configured to be a trip meter display, and that's resettable by pushing button 1 at any point here. But we also have an additional 2 buttons here, switch 2 and switch 3, which we can use to change what this displays. If switch number 2, that's the left hand switch, is moved to the on position, which is to the right, then this display will show the fuel in litres or gallons depending on the selected option. So let's just turn the fuel level down, 0 litres, and up again, which is around about 68-70 litres on the on the full tank. As we say, that can be configured for litres or gallons depending on the options that are set on the unit. We'll look at options set in another video. If instead of switch number 2 we switch switch number 3 on, then this display is showing the engine temperature following this gauge, and that can be displayed in centigrade, in which case it will show a C, or Fahrenheit, in which case it will show an F. So again, you see as we increase the temperature gauge, so the numeric display of temperature also increases. If both of these switches are in the on position, then it's displaying the voltage to the unit, which we can't actually change because we're using a fixed voltage supply, but on the real car that will go up and down with the supply voltage. So we have 4 potential displays here: trip, temperature, fuel or voltage, all determined by the state of these 2 switches here. And normally we'll have both of these switches to the left off, which is the trip meter display. These switches that we use, by the way, these button 1, button 2 and switch number 1, are all available at the edge connector. They're taken out into the harness, so external switches can be connected to these if you so wish, to make it easier to actually access the functions of the unit. From normal running mode, it's easy to go into another one of the modes that we'll look at in another video, which is show mode. All you need to do whenever you're in normal running mode to go into show mode is push and release button number 2. Push and release and it will go into show mode. And we'll look at show mode in another video. Push and release again will take us back into normal running mode. So that's the functions of the normal running mode of the unit.